All right, you see this? This is aponeurosis. It's a tendon mat, and these straps come down through these little holes, just like this one does. You see this? The strap goes through the hole, and the ball is on the end of the strap. It's supposed to be locked in here up to about just like what I just showed you, and it's supposed to be locked into here. Well, this one ripped out. That's an injury, and that's painful, but it's not the end of the world. It's just one of these balls. It's like when you get a knot in your stomach, that type of thing. They made these flat plates when they were still moist and cut them and used them in the walls and just broke these off right here. These are the bumps. They're just broken off right here. And these flat plates were perfect when they were moist, and they put them up in the walls and just left the plates, the little bumps sticking out. Now don't forget, I'm always talking about tendons, and there is flat tendons or mats which have the aponeurosis, and they have the balls and the straps, and then there's the big rope-like ones. And let me show you the difference. Well, there's two different styles. And there's probably more than that, but these are the ones that are obvious. Is the ones with the straps and the balls, in aponeurosis, the flat mats. And then, and I have an anatomical, I'll show you right now. So just really quickly, tendon versus aponeurosis. This is the flat connective tissue, thin sheets, flat. It allows the body to be stable, and the other ones are rope-like, and they're tough, and they're real tough cord-like. Now this is what they made the walls with primarily. They used both types, but now these are anatomical shots. This side is all the way out. This one gives you layer, but this would be the same thing here. They're not different. It's just that this allows you to see the ribs and all that stuff and the different layers of tissue. And the same thing here. You see the outside layer, then layer down. This is the aponeurosis. This is the type of tendon that is these flat plates, and they are locked in with those balls and straps. So they're sort of flat, but they're locked in. And then of course you have other tendons that are the rope-like ones, and then these are the rope-like tendons. And then they come out to a bunch of muscle, and then that pulls. But the tendon just gives you a little bit of movement. Now you see this line here, the linea alba? Right? That splits you right in half. And when these mud fossils got absorbed in the water, and then they dried out, they split, a lot of them, right down that line. Just barely cracked open, because what happens is as the blastula forms, that's the ball, when the baby grows to a certain number of cells, it flips inside. All right, so it just inverts inside, and then it seals up like this. So it comes out the ball like that, and then it goes inside, and the ball is like this, and this seals. And that seal is this linea alba. Now, if you don't want to see a female gigantic vagina, don't look. Alright, this is a Tracian womb cave, they call it. You see that little tiny split right there? That's the linea alba. It goes right up to, it's exactly dead center in the middle. You see that little tiny slit? Little bitty goes right up, right. That's the linea alba. Alright? Now, and obviously the rest is, obviously it's a vagina. And it's a real one from a real gigantic woman. Now, it also was what they call a coffin birth. And here's the baby. Let me show you the baby's face. All right, you look here. Look right there. This is his arm. The hand is broken off. There's the arm that goes up. This is his face. This is his nose, his eye, his nose, his lips, and all that. And he's breaking out of the side wall. They call that a coffin birth. When the baby is inside and they die, and it's just comes out. You see the tissue breaking through right here? The head is breaking through the wall. You see, this wall is just nice and smooth. I mean, they have the vagina ripples, but they don't. This is a baby popping out the side of the wall, right there. Now, there could have been another one. You know, I don't know. But this one, there's no question in my mind, that's the baby. All right, just look at her. And there's his arm right there, and the arm broke off right at the tip. He's coming right out through the tissue. And that is anatomically 100% undeniably correct. And the linea alba is there, so it's not like they came up and carved it. Nobody would have done that. All right, so here's my allegation, is that all of this was done when these things were moist, and they just broke off the little the tabs that went down to the balls, and they cut these out, slabs, whatever they could, and they just put them on top wherever they fit. And they just snuggled them in, and that's what made it. And the bumps are those little straps. All right, the reason I say that they were moist when they cut them is because of this. And they cut them with some kind of equipment. This is some kind of a machine. And where it came from, I don't know. It doesn't look like it drove right up here. It looks like it came out of the sky. Anyway, they were coming off here and cutting slabs and then moving them down to make these walls. Now, the size of these things was absolutely enormous. And you see this moss-looking stuff growing out of here? That is growing on some kind of biology that was in this particular strap, whether it was blood or I'm not sure what. Hold on one second. And I think I have, well, I think I have a test wall where they were testing what to do about these bumps. Hold on a second. You see this? That's the only thing I can come up with, is that they tried scraping them flat and see what happened. And then they tried leaving them like a little bump. And you can see that little pinch there? You see that? That's where that strap came out. And this stuff leading away from it, and these little patches here, that is all natural. That's natural. There's a skin, like all of that stuff is, and it's a blocky little thing that comes up so that it can float around. It's like a membrane that floats around on top of the really tough undercarriage here. But it's a nice muddy membrane, and it works good. And they look, I don't know what they were doing here. What would this possibly be for, other than to test out different methods of scraping these things down? And then eventually they ended up with just leave all the mud on the top and just break the tabs off. You clean them up a little bit so they don't look bad, and everything will be fine. And that's what they did. Now look at how elegant this is and how beautifully they did this. And you can see the different colored textures and so forth. And then they use all kind of different sized blocks. Some of them didn't have any bumps. Some of them had the bumps. It just depends. And they just cleaned them up, and they look very nice to me. Now this is a different story. This was on the end of town. They really didn't care much about. All they wanted was something to blockade. It looks like, why would they do this? They got walls and walls and walls. Now, you see this? This is all eroded away and rotting because they cut into the bone. They normally don't do that. Usually they just use the tendon and the hard stuff. But this is the blow up of this. Now, look at how rotted some of this stuff is. Look at that one there. That's just rotted meat. Look at that. I'm surprised they use that. You know, look, this is all, that's red, bloody. I believe that would have been a bone. And they just cut it and threw it up here. I don't know. They got all kinds of nasty pieces in this particular wall. Why? I don't know. Now, this is another tire track. You see that? That's the kind of a tire track a four-wheeler would have. They got those little bubbly things on the side so they can grippy And that's going over the top of a tendon that was drying out. That's a tendon. And I believe that's from Achilles tendon. These big straps. And it's tough. And the kids slide down them. It's really cool. You see that? That's a tendon. The kids turned it into a slide. I'll show you how they look when they're in full structure. Alright, this is an Achilles tendon. And these are the tendons they were using and cutting the slabs out of them. These are very, very good. Alright, so don't forget, I don't know how this thing got here. Unless it drove on these and then it locked these down so that it wouldn't slide off or something. Maybe that could be it. But somehow it got here. I don't know how. But it looks like it locked itself in up here so it wouldn't drift down here, and locked itself in here so that it wouldn't, so that it could go off the edge. Because something cut these slabs. They're very well cut. Alright, you saw that the Achilles tendon. This is Achilles tendon. These were cut off of here. Very, very nicely done. And then they put them back up here and made these walls. For what reason? I can't tell you. But I can tell you what. That's what this is. And they used these bodies. Alright, I guess I can do a real quick microscope shots of these specimens. Alright, I'm going to show you in the microscope. But this one right here is a fingertip, and that right there is a fingertip. Now, you'll notice the architecture, and I have it here where I'm going to look at it in the microscope. I'll show you. And this one here, the same thing. Now, you notice they're both broken off on the side here. You notice they have this exact same edge at the top. They have these two holes here that are plugged up. There's one here on here and one here that are plugged up. But on the other side, they're completely blown out. These are fingertips. Both of them are fingertips. Now this one is from Earth, the terrestrial one, and it just leaked out from the flood. It's flat as a pancake, see it? And the blood just leaked out of it from these different holes. This one, it exploded because it was wet coming through space, literally wet, and it exploded. Now, what's left is just the structure underneath all of the tissue. Now look at this. You see that? Look at that circle right there. There was another one right there. These are where the tendons come and they lock in. And then there was another one over here that exploded. That blew off as it came through space and heated up. This one's sealed off here, the black one, right? It's hard to see, but if you get it in the right light, you can catch the, whoops, that's where the vein was here and the vein over here, and at the end you can see it too, if you catch it just right. But anyway, the veins seal off, just like they did on this one. They sealed off, and right at the end it's sealed off, you see it? But on the other side, they completely leaked out. So let's take a look at the microscope of what the blood actually looks like where it's coming out of here. We'll put a little water on here and you'll see the blood, and then you'll see the tissue that coats this. And then on this one, it's pretty much burnt off. But we'll be able to find little spots of tissue here and there, and you'll be able to see the blood and the anchor. This ball is the anchor. And that was the stalk from that anchor. All right, that ball locked itself right into the guy's finger. And then that stalk ran up here into the tendon complex that comes down so you can jiggle your fingers around. All right, and I have another one here that's completely eroded. Now, if you can see that black, you probably can't, but maybe you can. That's what they call a distal phalanges. That's the artery, the vein, and that's the artery. And again, they seal off. You see it? That side's sealed off. Up here, it's sealed off too. All right, sealed off here, sealed off there. This side blew completely out. Same thing at the end, because it's the artery side. Artery side comes up and just blows right out. The vein side here, with the tube, you can still see the tube, seals right off. All right, and that black mark right there is what they call a distal phalanges. If you can catch it in the right light, you might be able to see it. And this was actually where the bone came out, right around here, somewhere around there. It's hard to see. It's very, very eroded. But that's the distal phalanges, that black shiny spot coming out there. All right, it's bone black, really, it's called. Okay, basically all the skin and the fabric and the fascia is this little fabricy stuff. And there's red and black blood in there, and then the white little fabrics. And that gives it a stretchability, and it coats all the organs. It's membranes, basically. All right, the next thing we're going to do is look at the red blood, the red blood, the red blood. All right, this side here is capped off, remember, because that's the vein side. But this side is completely leaked out its blood, and it turned into little crystals. And I'll show you what they look like. That's just solidified blood. That's all it is. I'll show it to you in a microscope. All right, so here it is in the microscope. Here's what it looks like up close. Now, I'm going to put a little bit of water on here and mess around with the light. See if we can get a little better shot of what this looks like. Now, let me put just a taste of water on there. All right. And it's just red and bloody. Now, I think it came out of that hole right there. And just puddled into here. Now that's one. There's 3 of them here. So here's the other one, where it puddled out itself. That's on the side. You see, it's all that red blood, and then you go down a little further on the side, and then there's another one right there. This one here is all filled up with dirt. But that's where that one is. You see, whenever they turn red like that, it's just still got saturated with blood. You see that? It's turned just almost like back into muddy mud again. You see, the other ones are hardened up like crystals. This one still has a muddy effect to it. Let me just lay it back here, and then I'll home in on it. I gotta get it settled here. All right, here we go. Now, you see that? This is nothing but red blood. That's literally just like red blood. Now, you wouldn't take it right from there. You'd drill down inside. Let me see if I can find my pick here. Hold on. All right, so you wouldn't just swipe it off of here. You would drill down inside of it. But you could see what it is. Look. That's just mud. You see that? You put a little more water on it. I don't even have to put water on it. It's just turning into mud all by itself. They're just saturated with blood. These are all little bubbles of blood. And that's what I'm looking at, is that fingertip that I showed you before. All right, and that is the same type of fingertip as the meteorite one right here. Okay, my friends, this is going to be very interesting. Avi Loeb is a Harvard professor, and he says aliens have visited. He's not kidding, and he talks about these comets being actually space vessels and harboring life on them. And this is Scientific American. This goes back to 2021. I've been trying to get a hold of Avi Loeb, and he hasn't contacted me back. But let me show you what he's talking about. Is Comet Omaru Maru was the first one he started with. Then it went to Psyche. I can explain both of those comets, and they are biological. This, my friends, is Comet Omaru Omaru. And it sped up as it approached the sun, just because of natural gravity. And they took it as it was a spaceship speeding up. And Avi Loeb, and I give him a lot of credit for speaking up, because he's at Harvard, and he's saying there's a crisis in science, absolute crisis, and he's right. This is a body part. Now, I showed this to one of the top anatomists, as far as I'm concerned, in the world. He's a sports anatomist. Well, there's two of them actually, and they do anatomy. They do dissections of bodies and everything. And I said, is this a finger? And he said, that's the fingeriest looking finger I have ever seen. Now, he didn't say it's a finger because it's out in space, and this thing is football fields long. Now, how do I know it? This right here is the crook of your finger. Right? That's right here. All right, there's another one right up here. There's a little twister up there that gives you a little, but this is the major one right here. Now, right up here is what they call an apical tuft. You see this white spot coming up? That tendon goes from where it attaches at the bone, and there's a bunch of little tiny holes at the ends of each bone, and that's where all these little tendons invest into those holes, and then they come up here and then they lock into the apical tuft, which is at the end. And I have one here, I'll show you. Then this little scruffy looking stuff here, that's skin. That's what's called grip skin. It's the really tough skin on your fingers that just erodes away because it's meant to erode away. It's tough. It does all the gripping. Now, so here we go to the first knuckle right there, that knuckle. All right. Then it comes down here to the bone ball, which is right here. You can see the the vein. The black one is the vein. The artery is over here, and the arteries have no color. They usually bleed out or whatever, but the black turns black. Now, these are the tendon tips as it runs right over the top of your knuckle. So this is the underside of the finger. All right. And these are all the tendons that run down, and they run right from that crease down this way and then up this way. That's the grip skin. Now let's take a look at the anatomical, and I'll show you. And again, these guys are the top basically in the world. They do this all the time. And there was no argument whatsoever. They didn't want to be associated with saying it's a finger because they're in business, and they're going to get slapped. That's just the way it works in academia. They will not let you speak unless they want you to speak and say exactly what they tell you to say. That's how it works. All right, this is probably the best shot I'm going to be able to give you of the palm of the hand and how these tendons come down. And we're looking at this crease like I was showing you here. And then there's another one at the tip. And these little tendon spits come down and they anchor into this right here. This is one of these. You see at the very tip? That's what's called an apical tuft. And all of these little holes have the tips of these tendons have a little tiny ball in them, and they lock into these holes. There's still one left that didn't fall out right on the very end. All the other ones have ripped out of here and just eroded out. Now this was at the tip of a finger from a giant fingertip. Now when I say these holes, you see these? These are the holes I'm talking about. All of these have little tiny balls in them, and the straps come down to keep this bone to work with whatever it's pulling against. The bones pull against each other and tendons and muscles and all that. But you have to anchor somewhere. These are the anchors. All right, and this is the anchors, the balls that would have anchored the tip of your finger. That gives you a lot of strength in the tips of the fingers. This is exactly what a maro is. And the The aponeurosis is this right here. Is this right there, and it does that. Now it reaches up to here. It's got to attach up here too, and the same thing here. That's the crease, and then it comes down this way. Then it broke off right at the top of the knuckle. You see this right here? That would have been over the top. This is the bottom of the finger, and there's your vein and artery, and these were the two. There's all kinds of tendons in here. And these are the two tendons that run up over the top to make your fingers do all that. Okay, you see this? Meet your interstitium, a newfound organ. This is March of 2018. They say that they just discovered this. Well, I knew about this back in 2009, and I contacted some people that worked in the fascia realm and interconnective tissues and sports injuries and all that. And we started communicating back and forth, and I said, I'm finding this layer that you guys haven't seen apparently, and that's exactly what it was, because by the time they autopsied them, they were flat as a pancake. They couldn't really look at them in this detail which we're looking at now. All these balls and all these fluid-filled highways, and they say exactly that. They say they discovered a new organ consists of these fluid-filled spaces in the body's connective tissues. They never saw them before because they flattened them out and dried them out and then dyed them and put them under the microscope. I use the full body because I can see it, and I can see them so big, it's amazing. You see these things? Don't forget now, if this eroded away and eroded away, what would you see? You'd see a bunch of balls that would be eroded down here and a bunch of fleshy stuff along with it. And guess what? I can show you that right here. There it is. That's the interstitium we were just looking at. Okay, this goes back, this goes from 2016. They started to understand about this in 2018. The paper was written that this was a new membrane area that they had never known about. But see these little tiny balls? See how many there is? This is a really shot here. And this is a very, very close-up shot. These are the layers of tissue and membranes and skin that protect you from getting down here into your fleshy stuff. And here's what it looks like when they erode off of a giant times a million creature. And here it is. There's a skin or mucosa, whatever you want to call it, or the fascia that coats the organ. And then these are that interstitium layer, and these are all of these little balls. And that allows you to move and go this way and that way and this way and come back to where you were in the beginning, because these are anchored. And they're on little straps. You can't see, well, in this one you can see the straps. You see the little tiny straps? They're on these straps. So this can bend and go twist and go sideways and this way and everything, because the bags of fluid can move around. But the ball is anchored. Now, once they erode so desperately, you end up with this, like these milky marbles. You see how many balls there are here? Well, guess what? There's just as many in these, too. That's exactly what the milky marbles were before everything eroded away. All the fleshy stuff, the fluid-filled stuff. You see? They talk about fluid-filled stuff. Even these straps are weak. The balls are tough. And that's why they lasted. See the balls here? They're still there. The balls here, they're still there. Now these don't have any nutrition left in them. See, they're just a hard metal ball now. These still have a lot of nutrition in them. See, there's all kind of thing growing on them. And here's all the mud that ran away, just because it's fleshy, you know, that fluid-filled fleshy stuff. So this is pretty conclusive as far as I'm concerned. Okay, my friends, this is another shocker du jour. I told you that I was going to show you balls on the walls and the straps and all that stuff. Well, there's a ball right there. And there's a strap coming down to that ball. Now there's another ball here, no strap. And there's a bunch of them all around. But this one still has its strap left. They call this the Arches National Park. I believe it's in Utah. And there was at one time some kind of a substrate here that ball anchored into, and I'll show you what it looks like in a living creature.